Good morning. No energy. Good morning. Thank you. Thank you. I want to make it a little more interactive. Let me start with a question. How many of us are here are transforming streamed data into lakehouses and data warehouses at 1 million events per day scale? Anyone here? Cool. One. Anybody else? Okay. Cool. So, sir, I will have a follow-up question for you. Do you persist the raw data? The raw data after, what would be the duration for the raw data?
Just keep it for 1 month.
1 month. Why?
I mean, because there's a stream right along that's coming in.
Yeah.
So it doesn't make sense for me to have a very longer retention for that.
Absolutely. Thank you.
Yeah.
Thank you for that. Well, so today I think we are going to talk about how we innovated in terms of persisting the raw data and use it forever. We don't lose a single event that is streamed into our platform, data platform. That is what we are going to see, what kind of innovation we have done. So let me start with a quick round of introduction. So redBus, as you all know, it's a ticketing platform. You all know that. Do you know MakeMyTrip, Queryable, redBus, all are the same company? Okay. So all three brands essentially are the same company. Okay, and I'm specifically from redBus, where we have done this innovation, and we are going to talk about this. So there you go. Our unified data platform, as I was indicating, so it is actually processing about 1.75 billion events every day, and it processes about 150 billion data points every single day. To give you just the scale, and we don't lose either of them, I mean, not a single of them, right? And this data into the data platform, what we do is, we have powerful ways of, powerful avenues for our stakeholders across product, tech, marketing, business, CRM, to derive analytics and use it for real-time decision making. So that is what our data platform is used for. And I think the few of the presentations before, pretty much it's the same, but I would still would like to quickly walk through this particular slide. So, okay, it works. So if you see the source, right? The source from all our channels like your web browsers, applications, backend servers that stream the data continuously into our platform. And we ingest this through Kafka, we ingest through RabbitMQ, and no HTTPS and no files as well. So based on the nature of the data, we have different processing. For example, the streaming application, the streaming applications data, it is getting processed through NiFi and Flink, whereas the batch data, we process through Parquet, Lambda, through GlueJobs. And storage, again, it depends on the nature of the data. For example, Imply, which is nothing but your Druid, Apache Druid, it's a product they've created on top of Apache Druid. We save all our real-time user behavior data into that. And this is enormous in number. And the data, Redshift stores the data marts and warehouse, etc. The consumption layer, as commonly, superset seems to be the industry standard. I've seen in the previous two presentations as well. We also use superset. And also we have got something, a proprietary lenses, which I will talk about in the later slides to come. We have alerts passing through emails, webhooks, and we have monitoring, Grafana, Prometheus, and orchestration, the infra orchestration, we have Kubernetes, and the task orchestration, we have Step and Airflow. We have also created documentation, a dynamic documentation platform. It's called using DocuSarus, where our data platform can be democratized. We have democratized our data platform using this documentation platform, which we call data catalog. So it is a very unique proposition. I will give you a glimpse of that as well as we move forward. So going to the next slide. Okay, this is the data catalog that we have created. If you see, there are multiple, business, the nature of the data here on the left side. I can click on that and find out all the tables under that, the warehouse tables. It also gives you how many rows are there, what is the size, who is the owner, if you want to talk to them, or if you want to visualize, you can directly click on this, visualize, and go from here. So it's a very innovative innovation that we have done, but we are not going to talk about that. We are going to focus on the real time, how are we going to persist the raw data and build power to leverage that. Okay, why raw data? As he's, why do you want to persist for a month, sir? So
the data is changing quite frequently. So we had a transactional system which like getting the data as a batch, and real time is something for operational purposes. Right. So don't keep it more than a month.
Yeah. So what kind of use cases you have built on real?
So I come from a food delivery domain, right? Right. So we had that. We have to do the operational monitoring, see how the riders are delivering at the right time or not. So, and for the machine learning algorithms. So just,
excellent.
Yes.
Excellent. Thank you for that. So exactly, we also figured out the raw data is of enormous use, in terms of troubleshooting. Because when, for example, a booking failure happens in redBus, to figure out just the information what we persisted is not enough. And what we need is the real raw data that was sent by the API. So for that, that is very important. Second, the data science, many times they come back and say, hey, you know what? I want to build this use case in the model. I want the data, and I want to capture this. It can be only, it cannot be retrospective, right? It can be only prospective. So how do we build retrospective at scale? So that is why we need the raw data to be available for us to process. So these are the cases why we thought we should start looking at the raw data to be persisted. To give you the scale, in our apps, it generates about 57 million events every day. I'm talking about only the 3 critical applications, the APIs. These 3 APIs, 3 sources, it generates 57 million events every day, which is like, huge, right? So if I have to save assets, it is going to create a data swamp. I cannot save assets. I have to find out an innovative way of how I save it more optimized manner. That is what is the problem that we had in hand. And also it should support how we can scale it, right? And also how we can leverage by using the potential, right? So these are the challenges that we had. Now, if I look at that, how we have the steps that we have solved, taken to actually solve this problem is, first, we understood that data which is coming in is through APIs, which is pretty much a contract exists. So it is between the systems. So if there is a contract, I already have the schema. But the challenge is the schema is ever evolving. Every day it evolves, right? As we grow, we introduce new fields and information into the schema. So it evolves. So we thought instead of tracking the schema, we thought, why don't we infer the schema from the raw data? The moment a raw data hits us, we will go and find out what is the schema. Then what we do is, once we get the schema, we will go and compare if the schema already exists with us. Already we already versioned it and it exists. If it exists, we will add to it with a new timestamp as the ID, or we will actually create a new schema itself. If assume it's a new event that is coming in for the first time, then it creates a new bucket. So these buckets are created, timestamp, and version. Now the bucket is there. The schema has been inferred. What we do next, we take the raw event, we actually do a upcast, the casting. We have some casting rules which we'll talk about in the coming slides. We do the casting, and we actually transform this event into the generic schema that we have inferred. The generic schema, what we have inferred, we transform this event into that. Then that data is getting compressed at the next level of optimization. We put this into a Parquet. Of course, Parquet is the data lake, new norm. Because of this efficient columnar structure, how it's store the JSON data. So we use Parquet. But again, after we transform into a Parquet, we actually merge this Parquet and put it in S3. And that is how we actually, these are the steps that we use to process this. Yeah. So this is the schematic, the schematic diagram that represents how we actually inference. What pretty much I explained you. So first, when the API services push the JSON, through Kafka, we take it, we extract the metadata. The metadata, what we extract is, because of luckily and fortunately, we have headers uniform across our API services. So like your country, your event source, etc. So we extract this. We include these elements into that event data itself. We include this metadata into that so that it can be queried, etc. And then we infer the schema. As I said, after inferring schema, we just go and do the schema bucketing. Once we bucket it, we transform, then publish to S3. So also what happens is, because of the very nature of our business, we end up generating small files, a lot of small files, which is a problem. So now I have to do a compaction. So the small files get compacted using this flow that we have indicated here. The small files are now identified, merged into Parquet files, and we publish it. So we have optimized that as well. So this is what I was referring to, how we actually do the casting, right? The raw data, if you see, these are the elements: time, source, country, then ID description, ID amount, success total, etc. So now we actually derive a generic schema out of that, which is like, which is in the middle, right? So this is the generic schema we derive from the raw data. Then we convert this into a Parquet schema. So once we do this, and also we have just captured, just in case if you are interested, if we have time, yeah, we have time, I'll go through this. So how we actually defined, because we have controlled how this upcasting will happen. For example, integer long, it is resolvable to long. Float double, resolvable to double. Boolean long, it cannot be resolved, right? So it cannot be resolved. Null any resolvable, we can put any. String and any primitive, we put string. So these are, this is just an indication, but there are multiple other rules that we use to actually upcast the actual event data into a generic schema and then to Parquet. So this also explains a bit, no more, just in case if you are too interested. So the two strings, how it is getting converted from the raw data to a schema, and that is a disjoint merge. Then we have mismatch where there is no merge, how we handle an array merge and a schema mismatch, just to indicate how we actually convert or transform the raw data into the generic schema. And once we generate this bucket, then we have to create a Parquet as well. The Parquet generation also follows a similar approach. Now, as I said, the metadata is our source, country, and event type. That is how it is structured, and then followed by the event time and the bucket ID, and we add the version time dot Parquet, right? Because Parquet file will have the version as the file name. That is how we have structured. And once we have saved into S3, now the next step is how do we actually leverage, right? How do we extract this data? How do we extract and leverage? What we have done is we have created a serverless extraction mechanism, where the data gets extracted using an application called Lenses. As I said, Lenses is a very important application that we have built. It's a powerful explorer what we have got. When a user inputs, for example, Singapore, I want the booking data from IST 11 a.m. The moment he puts that, this application, it calls this backend service, which creates a Parquet job. This Parquet job actually goes, take this filters version, find out the version, filter the groups, extract the data, and creates a SQLite file. And this SQLite file, it publishes into a S3 path and gives return the path to the user. So whenever the user wants to visualize this downloaded raw data, he can actually click on this link and view it in the browser. I'll show you how that also looks like. So if you see, this is how. So you key in your event source. For example, Omega is our inventory system. Then we actually put the geo as India. Then event type as tentative booking. Then this is the time, UTC in UTC. Then this is the MRI client ID or session ID, which is very unique, what we have built, like your GA, client ID, session ID. We have built for our own selves. So once you put key in this, it is going to generate this file here. And when you click on this file, it is going to give you the raw data here for you to check. Here clearly you see there is a fair mismatch error. So this you would not be able to see unless you have the access to the raw data. That is the powerful feature that we have built. Now how people can use the raw data to debug, the troubleshoot the production issues. And just some quick numbers. As I said, 3 backend services is what we have done this. About 2 quarters ago, we have about 45 APIs in all the 3 services. We serve 9 countries, and we have 5 instances, EC2 instances. The total data what we have is 31 terabyte. In the last 2 quarters, what we have accumulated, and roughly it cost us only $500 a month, only $500 a month. And more than 6 months, we moved to Asia, Glacier, and the AWS. We are basically AWS shop. We have all our infrastructure in AWS. So we have Mumbai, Singapore, and North Virginia for our Latin markets, Latin American markets. Our daily average, as I said, 5.7 crores, 57 million raw records we process. The raw size will be 2.1 terabyte, which means you roughly get 90 GB per hour. And the record size can vary from 1 KB to 12 MB also, because if you search for redBus, it might return all the matching buses with all this information that can go up to 12 MB also. So it's a huge size event that we get. What we have stored is, after extraction is 148 GB of data, and roughly there are about 24,000 objects, S3 objects. The compression ratio, what we were able to accomplish using our innovative IP that we have created for the raw data is 93%, which is 14.5 times. 93% compression. That's how we optimized how we can save this raw data forever, right? And filtering time, for example, for a 2-hour window, I extract this information. It happens in 5 seconds. Maximum, it can be a minute, based on the size of those events. As I said, some of the search events may be huge. That might take a minute maximum. If it is not so complicated, even, it will return in 5 seconds. That is the retrieval, the numbers that we have accomplished. Oops. Yeah, some of the challenges what we have faced in the solution that we have put together. One is one might think that you lose the fidelity, right? Because you guys are transforming to a generic structure. It is not the raw event itself. You put it in a So here, what we have to notice, we only lose the structure, which can be reconstructed if required, but the information is never lost. The raw data information is never lost, right? That is the most important thing. And matching overhead, and there could be multiple versions of buckets. So will it be a challenge to do multiple, across so many number of buckets? That could be one way of looking, but of course we are doing compaction, but still, this is the question. Right now, we have not faced it. And the structural dependency, I think we touched upon it already. Some of the benefits, as I said, the cost and performance, the key one, we were able to save this raw data, every piece of raw data that we get it into our pipeline for $500 till now. And with a compression of 13x. The data extraction, how we are extracting the data is like event pointed, as well as it can be batch processed as well. Batch processed we have still not done, but work is happening. And it has enabled analytics across the board, right from our CRM team to marketing team to our product managers to engineering managers to monitor the new feature launch, etc. It has become the way in redBus. Everybody uses lenses to solve their problems. Solution highlights elegant schema management, as you would have seen, how we actually elegantly manage the schema. Cost effectiveness, of course, and we can backfill. Any time you can go back in time, and if you want, for example, January 15th, 11 o'clock record, 11 to 12 a.m. Indian time, I want all the record to be reprocessed. We can do. So these are the solution highlights. With that, I want to ask all of you to ask questions, and I'll be very, very happy. And before that, the team which has given shape to this idea is here. Girish and Nitish, if you want to raise, say hi. They are the one who built it. Yeah. So we'll be happy to take questions.